Alright, so in this video we're going to talk about radian measure, arc length, and area. Alright, so basically what we're measuring an angle in radians rather than degrees. Alright, so this is really important because a lot of the formulas you use, which you'll see in this video that we're doing now, for like arc length, area for the sector of a circle, and in other videos, if you watch those, angular and linear velocity, whenever you're using those formulas, your angle has to be in radian measure. Okay, and then of course when you get into calculus and that kind of stuff, if you take those classes, all your angle measures will be in radians there. So let's go ahead and get started. So we've got a definition here, and it says the radian measure of the angle alpha in standard position is the directed length of the intercepted arc on the unit circle. All right, so this word, this term here, directed length, that means the radian measure is positive if the rotation of the terminal side is counterclockwise and negative if the rotation is clockwise. Okay, so if you have let's just say we have an angle here, we're in standard position, so we're going along the positive x-axis here. This is your x-axis, here's your y-axis, and we can rotate in a counterclockwise direction, say alpha. That would be a positive rotation. And then if we went this way, say we rotated this way, an angle beta, this would be a negative rotation. Okay. All right. So one of the things that we need to look at is degree-radian conversion. So this is important because a lot of times whenever you're given an angle, if you have a job or something and you have angle measures and stuff like that, typically your angle measure is going to be in degrees. And so we would need to know how to convert from degrees to radians. Okay. So, and it's also important to be able to convert from radians to degrees. So to convert from degrees to radians, you just multiply your degrees by pi over 180. And to convert from radians to degrees, multiply your radians by 180 over pi. So let's take a look at a couple of examples. We want to convert the degree measures to radians. All right. So here we have 270 degrees. So we take the 270 degrees and we multiply it by pi over 180. So just like it says here, multiply the degrees by pi over 180. And when we do that, so we'll simplify our answer, and that gives us, what is that? 3 pi over 2 radians. And that would be your answer. All right. All right, now what about this negative 23.6? So we've got negative 23.6 times pi over 180. And then you would just punch that in your calculator, and that gives you negative 0.412 radians. And there's your answer. All right. So if in the problem you're talking about angle measure, okay, notice I wrote the RAD. Now you may see it when you have a problem, when you're working a problem and they give you the angle measure, they may not have radians written there behind the number. And if they don't, then if this isn't there, it's in radians because there's no degree symbol. Okay, so if there's no degree symbol, you'll know that the angle measure is in radians. Okay, Now, the other question that I usually get from students is, how do you know when to leave it like this as like 3 pi over 2 or put it in the decimal? I mean, either way is correct, but typically what you see is, if the degree measure is in decimals, I just typically put the radian measure in decimals. And if the degree measure is not a decimal, it's something like this, I'll typically leave it in terms of pi. Okay, but that's me. You might want to ask your teacher, how they prefer. Some teachers may want you to do it different. All right, now to convert radian measures to degrees. So these are radian measures and we want to convert to degrees. So we've got 7 pi over 6. So we take the 7 pi over 6, and remember, to convert from radians to degrees, we multiply the radians by 180 over pi. So this is going to be times 180 over pi. And you can see here that the pi's, they will cancel out, and then you just kind of simplify, reduce your fraction here, and this comes out to be 210 degrees. And then same thing here, the 12.3 radians, multiply that by 180 over pi, and when you punch that into your calculator, you get 704.7 degrees. All right, so that's pretty easy, converting from degrees to radians, radians to degrees. It's not bad. You just got to remember what to multiply by. The pi over 180 to go from degrees to radians, and the 180 over pi to go from radians to degrees. All right, so let's see what else we've got. All right, find 2 positive and 2 negative angles using radian measure that are coterminal with pi over 6. All right, so this right here, this problem here is nothing new. Okay, if you watch the first video, we did this in the first video. Okay, the first video in the playlist. The only difference is in the first video, the angle measures were in degrees. Okay, in this video, the angle measures are in radians. So if you remember, when you're finding coterminal angles, so in other words, if you had 30 degrees, how would you find a coterminal angle? Well, you would add 360, right? And you could also add 360 twice to get another one. Okay, this was done in the first video. And it says 2 positive and 2 negative. So and this would give us a positive angle that was coterminal. And then if we added 360 twice, that would give us another coterminal angle that was positive. And then to get the negative ones, well, what we did is we took, like, for instance, the 30 degrees, and we did minus 360. And then we would subtract 360 twice to get another coterminal angle that was negative. All right. Now, this time we're in radians. Okay. So adding 360, okay, if we're in radians, we're going to add 2 pi. Okay. Because if you take 360 degrees and you convert it to radians, see that? That's going to give us 2 pi. Okay, so all we're doing for angles that are in radians, to find coterminal angles, we're either going to add 2 pi or we're going to subtract 2 pi. All right, it's the same thing that we did when we were in degrees, except for in degrees, when we found coterminal angles, we added 360. We subtracted 360. All right. All right. So let's look at this pi over 6. And we want to find 2 coterminal angles that are positive. So I'm going to add 360 degrees. But since I'm in radians, I add 2 pi, okay? And so when I add 2 pi, that is going to give me 13 pi over 6, okay? Now, let me just show you one time how we added the fractions. Normally, I don't do this, but all right, so we get, remember, you've got to get a common denominator. That's 2 pi over 1, okay? And so this would be pi. I've got to multiply the 1 times 6, so 6 times 2, that's 12 pi. And then when you add pi plus 12 pi, that's 13 pi. That's where that comes from, okay? So there's one of them, okay? So now let's add 2 pi again, okay? So I added 2 pi once, that gave me this. Now I'm going to add 2 pi twice. So just watch this. So I'm adding 2 pi, and then I add 2 pi again. So basically I'm adding 4 pi. But another way you can look at it is I'm adding 2 pi twice, okay? And so this is pi over 6 plus 4 pi, which that's going to be pi over 6 plus, and then if I get a common denominator, that's 24 pi over 6, which is 25 pi over 6. And so there's two angles that are coterminal to pi over 6. That's positive. Now let's find the negative ones. So I'm going to take pi over 6, and I'm going to subtract 2 pi. And so this would be pi over 6 minus 12 pi over 6, which that's negative 11 pi over 6. All right. So that's one angle that's coterminal, that's negative. So now let's subtract 2 pi again. So just like up here, I'm going to subtract 2 pi twice. Okay, so that's pi over 6 minus 4 pi, which is pi over 6 minus 24 pi over 6. And so that's going to give me negative 23 pi over 6. So there's an answer, there's an answer, there's one, and there's one. All right. Now, the other thing that I want to mention before we go on to the next problem. In trig, there's a lot of things that you need to just memorize. Okay? You've just got to know them. And the first thing I think that's important for you to just know, or, to memorize, is that 30 degrees in radians is pi over 6, okay? You can test it. You can do 30 times pi over 180, okay? And then the other one, 60 degrees, is pi over 3. 45 degrees is pi over 4. And then, of course, you've got 90 degrees is pi over 2. 180 is pi. 270 is 3 pi over 2. And 360 degrees is 2 pi. This right here, you just need to know it, okay? In other words, if you see pi over 3, you should automatically think 60 degrees, okay? Just know those. It'll make your life so much easier in trig if you just know that, all right? That's the main ones. All right. And then, of course, you'll come across some like 135 degrees, 120 degrees, 150 degrees, and stuff like that, okay? And, if you memorize those, that's great. That's good if you memorize those. And then, and you know, even like 300 degrees, 330 degrees, 315 degrees, that stuff. You know, if you memorize those in radian measure, that's fine. If not, it's not that big of a deal. But I think these are a big deal for you to know that. All right. So perform the indicated operation. Well, I kind of went over this a while ago. I just kind of threw this in here to refresh you on adding and subtracting fractions. Okay, and we did that up here, but let's just work these. And if you want, pause the video and work them and then play it and see if you got them right. All right, so here we get a common denominator of 6, so that's going to be 3 pi. This is going to be just pi, and so that's going to be 4 pi over 6, which is 2 pi over 3. All right, and then this one, pi minus pi over 4. Well, get a common denominator of 4, so that's going to be 4 pi pi, and this is going to be 3 pi over 4. And there's your answer. Okay, so that's, like I said, that's just a quick refresher on adding, subtracting fractions. You should already know how to do that if you're in trig, but just a quick refresher. All right, now let's talk about this arc length. The length S of an arc intercepted by a central angle of alpha radians on a circle of radius r is given by S equals alpha times r. Okay. All right. So if we draw just a quick little picture of this, here we have a circle and we have a angle here. All right. And this angle is alpha. Our arc length is S, and here is our radius. That's from the center to the point on the circle. That's R. So that's what a picture looks like. Now, the important thing here says the length S of an arc, which is this length right here, the length S of an arc, intercepted by a central angle. So remember, a central angle, that's where the vertex is at the center of the circle, of alpha radians. That's what's important right there. Okay, of alpha radians. So what does that tell us? That tells us that our angle measure has to be in radians. Okay, our angle measure has to be in radians on a circle of radius r, and of course here's your radius right here. All right, so the arc length is alpha times r, the angle measure times the radius of the circle. All right, so let's look at some examples. So find the length of the arc intercepted by the given central angle alpha in a circle of radius r. So they give us the angle measure and they give us the radius. All right, so remember, arc length is, and look, what I would do, just write that formula down every time and just plug the stuff in. Alpha times r. So we're looking for the arc length. So the arc length is alpha. Now look at this. See, this goes to what I was telling you earlier in the video. See, alpha, they just have pi over 8. They don't have that RAD written behind it for radians. But notice there's no degree symbol there. This angle measure is in radians. That's what I was trying to explain to you earlier in the video. All right, so that's going to be pi over 8 times r, which is 30. Okay, and so the arc length, if I do 30 over 8, that is going to give me 15 pi over 4. Okay, now what are we talking about? Well, look at this. Here's our circle. Okay, There's our angle measure. Okay, here's alpha. This is our pi over 8. The radius is 30. And we're finding this arc length here. And we found that arc length to be 15 pi over 4. And now what is this? This is yards. Okay. Now, in this problem, you know, this 15 pi over 4, that may look like an angle measure to you, but it's not. We found the arc length here. And if you do 15 pi and then divided by 4, this is the same thing as 11 point, and I'll round to 2 decimals. It's 11.78 yards. Okay. This right here, this is the same thing as this. They're the same thing. It's just I punched it in my calculator and got a decimal. Now, how does your teacher want you to put it? I don't know. Ask them. Okay. Ask them if they want you to leave it in terms of pi, or if they want you to round it to however many decimal places. Okay. As far as I'm concerned, if you're in my class, I don't care which way you put it. Okay. But, you know, make sure you put the yards behind it. All right. So here we have another one. We've got S equals alpha times R. Okay. All right. So alpha in this case is 3 degrees. Okay. Well, I've got the angle measure, but it's in degrees. It's not in radians. So I have to convert this to radians. So I'm going to come over here to the side, and I'm going to say alpha is equal to 3 times pi over 180. Okay. And if I do 3 over 180, what is that going to simplify to? That's going to be pi over 60. Okay. So this is the angle measure that I use. Okay. Because your angle measure has to be in radians. I can't stress that enough. Students always miss that. All right. So I've got pi over 60 times the radius, which is 4,000. And I don't know if 60 goes into 4,000 evenly. We'll see. It does not. So let's see. 4,000 over 60. And then let's see, what is that? That ends up being 200 pi over 3. And that is in miles. Okay, so that's the arc length. Now, like I said, let's go ahead and just punch this in the calculator. So 200 pi divided by 3, that is 209.44 miles. Okay, so either one I would accept if you're in my class, but like I said, ask your teacher. All right. Now let's see what we have here. Find the radius of the circle in which the given central angle alpha intercepts an arc of the given length S. All right. So in this problem, we're looking for the radius. All right. So let's write our formula down. All right. And then let's plug everything in. So we've got S, that's 99, and that's kilometers. And that is equal to alpha, so that's in radians. There's no degree symbol there, 0.004 R. Okay, so I just plugged everything in, and what do they want us to find? The radius. So I plugged in the arc length, I plugged in the angle. My only variable is R, which is my radius. So now I just solve for R. So I divide everything by 0.004. And so I get my radius is, let's see, 99 divided by 0.004. That is 24,750 and that is kilometers. And that is the radius of the circle. Okay, so just quickly to draw this thing. All right, so they're giving me the alpha, which is 0.004 radians. They are giving me this arc length right here. Let's just see if we can kind of make that a little darker. The arc length is 99, and they're wanting me to find this radius here of this circle. That's what I'm looking for. All right. All right, so let's look at this one. So same thing. They want me to find the radius. They're giving me the angle. They're giving me the arc length. So let's write our formula down. S is equal to alpha times R. Now, let's plug in the 10. All right, that's my arc length. Now alpha, okay, you don't plug in 180. Okay, that's in degrees. So we got to come over here. Alpha is 180 degrees times what? Remember how to go from degrees to radians. Pi over 180, which equals pi. Now, let me say this. What I did here, this right here, you should not have to do that, okay? Because remember what I told you earlier, that 180 degrees, that's one you've got, just memorize it. So when you see the 180, you shouldn't even do that. So when you see the 180, you should automatically just plug in pi, okay, and times R. All right, so now we have to solve for R. So I'm going to divide both sides by pi. And so I get R is equal to 10 pi, and that would be I'm sorry, not 10 pi, but 10 over pi kilometers. And we can go ahead and punch that in our calculator. So 10 divided by pi, that is 3.18 kilometers. And that's the radius of the circle. Okay. All right. So you see, it's really easy. So when you're dealing with arc length, angles, and radius, whatever they're wanting you to find, it doesn't matter. Okay. It doesn't matter what they're wanting you to find. Just write the formula down and plug in the information you have and solve for the other variable. See, in these problems, they could have just easily asked us to find the angle. They could have given us the radius and the arc length and said, what's the angle? Okay. All right. So let's look at this one. All right, so we only got this example here and one other one. All right, so here, find the exact area of the sector of the circle with the given radius and central angle. All right, so before we work this problem, let's look at the area for the sector of a circle. Okay. All right, so when I was writing up the stuff for this video, evidently I forgot to write down the theorem for the area of a sector of a circle, so I just went ahead and wrote it down. All right, so the area of a sector of a circle, the area A of a sector with central angle alpha, notice once again the parentheses, in radians. Your angle has to be in radians, and a circle of radius r is given by A equals alpha times r squared over 2. So let's just draw real quick what we're doing here so you can see what's going on. There's a circle. It's not a good one, but let's pretend it's a good circle. All right, so I've got alpha, I've got r. So what we're finding here is this area right here of that sector. That's what we're looking for. Okay, this is your A. That's A, this area right here. All right, so you have to know that formula. All right, so let's look at this. It says find the exact area of the sector of the circle with the given radius and central angle. All right, so we've got R is 8, alpha is pi over 12. All right, so let's find the area. So let's look at the formula. Let's write it down. So our formula is A is equal to alpha times R squared over 2. So we just got to plug everything in. Okay. All right. Now, before we go on, okay, one thing I want to point out. Now, using this formula is similar. It's just like using the other formula for arc length. Okay, you just plug everything in. Just make sure your angle is in radian measure and not degrees. All right, so what we've got to look at here in these directions, find the exact area, with this being the important word here. What in the world does that mean, the exact area? Okay, that means they don't want you to punch any of this into your calculator. Okay, you've got to give an exact answer. You've got to they want you to leave your answer as a fraction or whatever it is. Okay, you'll see this word quite often in trig. Give the exact answer. That means don't use your calculator. Okay. All right, so let's plug everything in. So we've got A is equal to alpha, which is pi over 12, times R squared, so that's 8 squared over 2. Okay, so this is going to be, well, that's going to be 64, right? So pi over 12 times 64 over 2. Now, we've got to simplify this thing, don't we? So, I don't know. Let's look at this. Let's do it like this. 64 pi over 12 over 2. Now, we know this 2 is over 1, so that's what? 64 pi over 12 divided by 2 divided by, or what? Times the reciprocal, right? So let's see. We get 64 pi over 24, and we need to simplify that. Well, 8 goes into 64, 8 goes into 24. So that will give us what? 8 pi over 3. Okay. Now, notice in this problem, I don't know why they didn't do it, but they didn't. They didn't give us units, what this is in. But just remember, whenever you calculate this is square units. Like if it was in feet, it would be square feet. If it was in inches, it would be square inches. We're talking about area here. Okay, and so there's your answer. All right, so let's look at this one. All right, so write your formula down. A is alpha times R squared over 2. All right, so the problem we have here, our angle is in degrees, so we have to convert it to radians. So, all right, now this is one of the ones you have to know. So alpha is 45 degrees, so that's pi over 4. That's one of the ones you need to memorize. Okay, I'm telling you, it's really important to know those. 30, 45, 60, 90, 180, 270, 360 degrees. Know the radian equivalent. Okay, and of course 0 degrees is just 0 radians. All right, and so that's times 4 squared over 2. And so this is going to be pi over 4 times 16, that's over 2. And so look at this, 16 pi over 4, that's just going to be 4 pi, right? See, that and that cancel, left with a 1 and a 4. And so this is just 2 pi, and that's square units. And so there's your area. Okay. All right, so I hope all this is making sense. Okay. And just remember, the reason that we're leaving our answers like 8 pi over 3 and 2 pi is because they told us to find the exact answer, this right here, exact. All right, so let's look at this. A bicycle has a chain that connects a chain ring of radius 6 inches with a cog of radius 2 inches. Okay. If the chain ring rotates through an angle of 20 degrees, then through how many degrees does the cog rotate? All right, so I think the best thing to do here would be to just kind of sketch a picture of this thing. Okay, so here we have, let's draw this. This one would be there's the chain ring. That's the one with the pedal on it. I know that's not a good drawing. And then we have the cog ring. That's the one on the back wheel that's smaller. And then you've got the chain coming like this. Okay. All right, that's the best I can draw. I'm not good at drawing. That's the best I can do. All right, so we know that this radius here is, whoop, erase that. This radius here is 2 inches. And this radius here is 6 inches. Okay. So it's telling us that the chain ring rotates through an angle of 20 degrees. Okay. So in other words, you know, if we're starting, let me erase this and draw it. Let's draw it right here, 6 inches. So what we have here, if we're starting at a point right here and it rotates through 20 degrees, they want to know how much does, if we have one here, how much does it rotate? What's that angle that it's going to rotate? Well, the way that we can find that is when you're looking at this, if this rotates, it doesn't matter how much this rotates past, this chain's moving, okay? And however much the chain moves on this one, the same amount of chain is moving on this one. So what we can do is we can find, okay, what's the arc length over here on this 6-inch chain ring? What's that arc length? And then we can take that arc length and plug it into the formula for the radius of 2 inches and solve for that angle measure. All right, let's work through it. Maybe it'll make more sense. All right, so I've got S equals R times alpha, alpha times R. It doesn't matter. All right, so we've got, in this part of the problem, alpha is 20 degrees times pi over 180, okay, which that is pi over 90. No, not pi over 90. Pi over 9. Yeah. Let's see, 2 over, I'm just making sure I get this, getting all my arithmetic right. You know, pi over 9. That's my angle measure. Because when I mess up with the arithmetic, make a careless mistakes, I always hear it in the comments. So just making sure I get everything right. All right, so we got S is equal to, so alpha, that's going to be pi over 9 times R times my radius, which is 6 inches. Whoop. And so this is what? 2 pi over 3 inches. That is the amount of chain that moves. So if you start at a point and this thing rotates through 20 degrees, okay, it rotates through 20 degrees, this is the 2 pi over 3. That's how much of the chain moves. So that same amount of chain moves across this smaller one, but it's going to do it over a wider angle. Okay? You see that? Because see, this amount of chain here is probably about the same amount of chain as, this. All right, if we took this and overlaid it over here, it would cover up more of that circle. Okay, so that's what we're doing. So we found the arc length that it moves through. So now we go back to S equals alpha times R. So we've got the arc length, which is 2 pi over 3, equals alpha times the radius. Okay, so alpha, that's what we're looking for. The radius is 2 inches. So 2 times alpha. All right. So if I multiply through by 1/2, that's going to give me pi over 3 equals alpha. All right. See that? I multiply by 1/2 to get rid of that. And so now I get alpha is equal to, that's pi over 3 radians. Let's give the answer in degrees because it didn't say, well, I don't know, let's see. If if the chain ring rotates through an angle of 20 degrees, then through how many degrees does the cog rotate? So pi over 3 radians, that is 60 degrees. Okay, so this 2 pi over 3, that arc length, the big one rotates 20 degrees to get the 2 pi over 3 arc length, but the smaller one has to rotate over 60 degrees to get that, and that's what they're asking for. All right, so that was the last example, and it's not bad. It's what you do. It's what we did in the first video, except we're working with the angles in radians rather than degrees. Okay. All right, so I hope the video helped. Check out my other videos. Give me a like, share, and subscribe, and thanks for watching.